Hello, so in this video we're looking at how to find values using composite functions. So basically what they've done is they've given us three functions, the f, g and h functions, and then they're asking us to, of these composite functions that they've made, find the value when we put x as certain numbers. So in this first one, they're saying, what is f g of 1? Now, for questions like this, there are really two different ways of doing it, and I'm going to show you, first of all, those two ways. One, I think, is definitely easier than the other, so then for the other questions, we'll just use the easier method. But I want to show you both so that you know what they are. So, method one would be to, first of all, find the composite function that you need. So, find the f(g) of x function. And then once you find that function, you can sub in whichever value you want. Yeah, so you sub in your x value. In this case, you sub in 1. In method 2, you first of all find g of 1, because g is closer to the 1. So you find g of 1 first. And then whatever you get from that, the output of that, you plug that, or you substitute that into your f of x. So find g of 1, find the answer, so say it's like 5, and you plug that 5 into the fx function. So both of these will be the same. This method is, I think, a lot easier, but let's just see what this method will give us, just so you've seen both. Okay, so if we want to find the f(g) of x function, we take this whole g function and we put it in here to the f. So we're going to say f(g) of x equals, and then we do this bit, so we have the 3 minus 4, but then instead of x, we're going to put this whole g function. So we're going to have x minus 3 squared, like that. And now that we've found that, we can now find f(g) of 1 by plugging 1 into here. So we can do 3 minus 4 sets of 1 minus 3 squared, which if we simplify that would be 3 minus 4 sets of 1 minus 3 is negative 2. So negative 2 squared, which we can then simplify one last time to get 3 minus 4 times minus 2 squared. So minus 2 squared is 4. 4 times 4 is 16. So we got 3 minus 16, which is negative 13. And that's our answer. So that's one way of doing it. But now if we try it this way, let's first of all find g of 1. So for this, we just plug 1 into here. You get 1 minus 3 squared, which is going to be minus 2 squared, which is 4. And then, now that we found out that's 4, we can now plug 4 into our f function. We find f of 4, which is going to be 3 minus 4 times 4. Because remember, we're putting 4 into here, which is just 3 minus 16, which is minus 13. So in both cases, either way that we do it, we get minus 13 as our answer, which is what we expect. So I think in general, method 2 is a bit quicker. Same number of steps really, but I think method 2 is a bit easier. So if we now scroll down, what I've done is just repeated the question, just so we can see it. And let's try the method 2 approach to B. Okay, so for B, the first thing we want to do is find f of 2. So f of 2 means 3 minus 4 sets of 2, which is 3 minus 8, which is minus 5. And then we do g of minus 5, which is going to be minus 5 in place of x, minus 3, all squared. Minus 5 minus 3 is minus 8, and we square the minus 8, and that gives us 64. So 64 is our answer. Then for C, there's now like 3 letters, so 3 functions within this one composite function, but we still apply the same rule. So first of all, we're going to find g of -9, which is x take away -9. Oops, sorry, my bad. The x is -9, so -9 minus 3 squared. -9 minus 3 is -12, so now I've got -12 squared, and that's 144. So now we have 144, we can do the next letter, so h. So we now find h of 144, and h of x is just x over 6. So this is going to be 144 divided by 6, which is 24, I think. And then we can do f of 24. So f of 24, and that's going to be 3 minus 4 times 24, which is 3 minus 96, which is minus 93. And that's it. So hopefully you can see that even when there's 3 subfunctions, it doesn't really make any difference. You just do one after the other. So if there were like even 10 subfunctions, if it was like g of f of f of g of g of f and so on, you still just apply this all over and over and over again. And I think that's where this method is a lot easier than method 1, because as you get more and more functions, method 1 becomes a little bit hard because you're just finding the actual normal function. So last one here is d. So remember, if it's f squared, that's really just asking us what is f of, I don't know where I got a g from, of h of 9. So the f squared just means ff, so you're just plugging it in twice. So first of all, let's find h of 9, which is just 9 over 6, which is 1.5, or we can simplify it to 3 over 2. Then we can find f of 3 over 2, which means that we have 3 minus 4 sets of 3 over 2, which means 3 minus 4 times 3 is 12, 12 by 2 is 6, so 3 minus 6, which is -3. And then we do this second f, which means f of -3, and that gives us 3 minus 4 sets of -3, which is 3. And then 4 times -3 is -12, but you're taking away negatives, so it's plus, so 3 at 12 is 15. And that's it. So I hope these make sense. It is entirely up to you which method you want to use. I normally find method 2 a bit easier, but it really depends. Often in exams, they'll ask you to find something like fg of x first, and then they'll ask you to find fg of 1. In which case, for that part B, you can just use your part A answer. So it really depends on the question. If you have any questions though, then let us know. And otherwise, I'll see you in the next one.